15.3 is exponential functions, and I titled it Applications of Exponential Functions because a lot of the problems are real world problems that are application problems. So the main thing in this section is to become familiar with your calculator and how to arrive at the answers that I present here. So you might have to play around with your calculator in the order that you type things in. And also you have to be careful on rounding and plugging in the values in the appropriate spot. So this first one, they give you a formula that says f of 0.4 is equal to this. And what you do here is you just substitute this input value that we've been doing all along this module or chapter, and you substitute in for x here. You can see I wrote out what you would type into your calculator here. You might have to research a little bit how to type E, Euler's number, into your calculator, but you should be able to work around with your calculator to come up with this solution. And then this problem doesn't tell you to round it to any specific spot, so I kind of wrote it out to 6 decimal places here. Okay. Now the second problem on the notes talks about compound continuous interest. So the interest is being compounded continuously. That formula is this here, and some people remember because there's a shampoo named PERT. Okay, so this A stands for the accumulated amount in the account, P stands for the principal or the money, E is Euler's number, which is about 2.71 or 2, and then the rate is the decimal, and the time in years. Okay, the rate's often given as a percent, and then you have to write it as a decimal. Okay, so I put in our values here that are given in the problem: $8,750, 9%. Make sure you change your percent to a decimal properly, and then 16 years. And we type this into our calculator, and we come up with this. Now, be careful. Sometimes they ask you what was the interest. Now, this is the total amount in the account. So if they ask for the interest, you would have to take this new value, this $36,931.09 approximately, and you'd have to subtract off your initial investment. Okay, so this was the total in the account, this was the investment, and then that would equal this would equal your interest. Okay, but this problem doesn't ask for that, but occasionally they will ask for that. Okay, now on problem 3, and I didn't number this problem here, but on problem 3, they say that the interest is compounded quarterly. So this is the compound interest formula when it's not continuous. And there's different types of compounds. There's compound daily, compound quarterly, compound semi-annually, compound monthly, and you'll have to learn what your N value is for those different ones. So monthly, there's 12 months in a year, so for monthly it would be 12. You might have to look some of those up. The strangest one for me is semi-annually, which is 2. Because biannually is also 2. Okay, so I plugged in my values here. The money, this 1 is part of the formula, and then we have the rate, 7%, compounded quarterly, and for 4 years. I don't like this problem too well because we repeat the 4 here, but this 4 right here, this actually stands for years. Okay. And this is because of quarterly. All right. So once we plug the values in, we can work with our calculator and come up with this $11,219. And again, this is the total in the account. So if you need to define interest, you would take this 11,000 minus the 8,500 if you need to define the interest. But this problem asks for the total amount in the account. So we're done with the problem there. So be careful with your substitution, round things properly, and use your calculator correctly.